Okay, and then you have in the another column, you have topics. Okay, so you have my lectures, right, as a playlist. So from that, you will write down the topics, jot down the topics. Okay, 8 lectures, 9 lectures, how many lectures, whatever the number of lectures must be, jot that down. And then next step will be on the date which it was done in the class. Okay, date in class, and then a revision date. Okay, and then revision date. So let us say you have topic 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so 8 classes. Let us say we have for chapter solution or something, and then you will write the dates here. Okay, so this topic was completed at this date and this date and this date. Then revision dates. Okay, so revision dates should be, first of all, you will revise the first topic, then second topic, then third topic. Okay, and then again, what you are going to do in the next set of revision, you are going to do all of these 3. Okay, then 1, 2, 3, then all of these 3, then 1 and 2, and then all of these chapters. You have to revise it like this. You got my point? Yes or no? What I'm trying to say here?
Yes, I understood.
Okay. What about you guys? Krishna, Hamza? Late I
Yes,
have. Okay, so you have maintained something. You can say that this is my track of learning. Okay, so try to encompass many things in your learning methods. Okay, so try to do this, and all of these things you can try only on holidays, right? Only on vacation. Because in vacation you have a lot of time in which your brain is vacant and you can think of many things to do. You also have time in order to search and look for some methods of studying. Hi Akshay, how are you?
Fine, sir.
Fine. Okay.
Good evening.
Good evening. Good evening. Okay, so please try to start revising this chapters. Okay, I have also put it in. I almost everyone's remark that you have to start revising now, because we have completed how many chapters? You have completed 2 chapters, right? And that is why also I'm conducting a test on next Saturday of the chapter solution. Now, once solution is done, then in the next week or after 2 weeks, I will be doing haloalkanes. Okay, and then I will be doing again a test in which I will be conducting solution plus haloalkane. Okay, so slowly I will reveal up the schedule for test, and please start to prepare at least 5 to 6 days. Okay, that is why I have given you the time so early that you can start trying at least 4 days. I will say at least 4 days. Why 4 days? Because approximately you can divide a chapter into 8 topics, and you can do at least 2 topics in a day. Okay, you can do at least 2 topics in a day. That is why you start at least 4 days before. 2 topics, and then you are going to do revision on the day in which you have examination. Okay, revision on the day in which you have examination. And meanwhile, whenever you are revising, please try to make short notes. Short notes are immensely helpful in your revisions. Okay, and when you have short notes, you even don't want to attend the revision lectures that I will be doing. Why? Because when you already have short notes, you don't need the lectures. What do you need? You need to practice the question with your short notes in front of you. Okay, try to start thinking about the day you are going to have examination. 11th बहुत ही नजदीक अभी आप लोग का था, right? So I hope you still remember how it feels when you see the question and you are like, okay, fine, I have seen this question somewhere in my notes, somewhere in my notebook, somewhere in the class, but I don't know how to do it. So please keep that sense of feeling in your mind, and then also put up in your brain that you will be having the board's examination. And if you feel like that, so I hope you all don't want to feel that thing, right or no? Yes or no, Akshay? Do you want to feel that I have seen this question somewhere, but I don't know how to do it?
No, sir.
No? You have felt that before?
Yes. But
yes, right?
not in finals, but I have.
You have, right? So please remember that feeling. है ना? I don't think in my student life, the whole student life, I don't think anything is worse than that. That you have seen something, and it's like if I would have put a bit of more effort, then I would have done this question one. I would have done this question correctly. Okay. So please grab on that feeling, है ना? And try to not make yourself feel worse than that in your board examination. Okay. Fair. And our only goal is to क्या करना है हम लोगों को? You only have to put in efforts, right? Like put in our hours, right? We have to just put in hours and don't forget about the result that you're going to get. If you are going to put in hours, if you're not going to get, for example, let us say you have put in all the efforts, all the work for 1 year, complete 1 year for 12th standard, but somehow, let us say due to some reasons, you could not perform well in those 3 hours. Right? You cannot perform well on those 3 hours, but still, whatever you have done preparation for the 1 year, that will stay with you. I mean, not the content of chemistry or physics or biology or maths, whatever you're studying, but that feeling of putting in effort, that feeling of getting marks in your term examination, in your unit test, and that feeling of knowing something, okay, that feeling of knowing something, that will stay with you. And then you will remember that, okay, fine, even if I did not get any result on those 3 hours, but that 1 year preparation is still with me, and you know your potential, that you can put in 8 long hours. Okay. So this time of 11th and 12th, you will always be remembering in your whole life that I used to do this much efforts, right? In my 11th and 12th standard, I used to study this many hours. So I can study these many hours now also, even when you are studying in your bachelor's or engineering or your medical classes or anything else also, if you're doing any graduation in science. Okay. So in the last lecture, we completed what parts? We completed the classification is done. So we'll write the methods of preparation. Okay. So please write the topic. Method of preparation. Methods of preparation of alcohol. I'll write the number 1 topic. By using haloalkane. Please remember, we are only going to talk about alcohols as of now. For phenols, we'll be looking after alcohols. Okay, we'll be looking after alcohols. The first one, please write using haloalkanes. Please write when. You have already seen this reaction in the chemical properties of haloalkanes. When haloalkanes are treated with aqueous KOH or NaOH, they form corresponding alcohols. They form corresponding alcohols. Right, next. We have RX, that is haloalkane, plus aqueous which is going to give me alcohol plus KX. You can also use one more reagent, that is AgOH. It's not there in NCERT, but sometimes they can give you this. Okay, you can use any metallic hydroxide and you will be getting subsequent alcohol. You will write is important. Please write tertiary alcohols cannot be prepared using tertiary haloalkanes. Using tertiary haloalkanes. Why? Because tertiary haloalkanes undergo elimination and gives alkene with alcohol. So both of the products are being formed. Okay, so if you have a tertiary haloalkane such as CS3, carbon CS3, CS3, and we have here Br. Plus, if we have aqueous KOH, then you're going to form CS3 C double bond CH2 CS3 plus. So this is an alkene via elimination reaction, and CH3 carbon CH3 CH3OH. This is alcohol. This is coming via substitution reaction. Okay, so elimination and substitution, they always have a competition between them because we have an electron rich species that is OH negative. Now this is why organic chemistry is not deterministic, it is very probabilistic, in the sense that what is the probability of happening, elimination reaction, what is the probability of having substitution reaction, and that probability will determine the amount of products that we are getting alkene, how much alkene we are getting in percentage, and how much alcohol we are getting in percentage. Okay, so when you have this OH negative, it is electron rich, okay, and it can act as both a nucleophile as well as a base. If it is acting as a base, that means it is abstracting the hydrogen atom and then it is forming alkene. It can also act sometimes as what? It can also act sometimes as nucleophile. And if it is able to attack on the carbon atom, it is acting as a nucleophile and it forms alcohol. But sometimes it will just attack the hydrogen atom. Okay. So in that sense, both of these reactions happen simultaneously: elimination reaction and substitution reaction. And you also get the products similarly, alkene and alcohol. Okay, so I hope now in your mind you can always think about the probability of happening elimination versus substitution. Elimination versus substitution. Write this down. And this is from the point of view of conversions. Whenever you have been given a tertiary alcohol, you will never think about having any haloalkene as the precursor. You will not think about having haloalkene as a starting material. Okay, so if you have a 2 degree or a primary alcohol, then you can think of haloalkene as its starting material, but not for 3 degree alcohols. Okay, write this down. Let me know when you're done. Done, everyone? Yes, no, please tell me.
Done, sir.
Right, next. By reduction of aldehyde and ketones. So right here, aldehydes and ketones can be easily converted to alcohols using the following reagents. Number one is hydrogen in the presence of, we can use nickel or platinum or palladium. Okay, so if you have H2 in the presence of nickel or H2 in the presence of platinum or H2 in the presence of palladium above the arrow. Okay, if anything like this is present, then you are going to do what? Reduction. Secondly, we have lithium, aluminium hydride, lithium, aluminium, hydride. This is also a reducing agent, a very strong reducing agent. Third one is NaBH4, sodium, borohydride. Fourth one is sodium in the presence of C2H5OH, that is ethanol. So these are the four reducing agents which we will be using in order to convert aldehyde and ketones to alcohols. We will see how the aldehyde is going to get converted and how the ketone is going to get converted and what kind of product they are going to give. Please write. The next point that you are going to write is aldehyde gives primary alcohol. Aldehyde gives primary alcohol. Ketones give secondary alcohol. So please see how is this going to happen. For aldehyde, we will have R, some C double bond O, and a hydrogen. Now, whenever I'm going to do reduction, what is going to happen? The hydrogen will get added on the C double bond O. So what is going to happen? You will have a hydrogen attached on the oxygen atom. You'll have a hydrogen attached on this carbon atom. Okay, and this pi bond is going to break, and you'll be forming R, C, OH. This carbon gets, this hydrogen was already present, and gets a hydrogen here. So this you can see is this carbon atom, which is our interested carbon, carbon of interest. This carbon atom is connected to only one carbon. That is why it is primary alcohol. Primary alcohol. And you can see here that C double bond O, pi bond is breaking, right? And then we are forming a CH bond. This is formed, and there is a OH bond which is formed, right? Similar thing is going to happen if you have ketones also. R, C double bond O. Let us say you have some R dash here, and if you are using what you are using here, let me write LiAlH4. Okay, any reducing agent, whatever we have written earlier. If you're using any reducing agent, then again here also hydrogen will come attached. This carbon will also get hydrogen, and you are going to get what? R, C with OH, and here you are going to get hydrogen, and then R dash as it is. Now this carbon atom, which is the carbon of interest, it has the hydroxy group here, the OH group here. That is why this is our carbon of interest, and it is connected to two different carbon atoms, and hence it is secondary carbon or secondary alcohol. All of you understood this? Yes or no? Please tell me.
Yes, sir.
Okay, great. Atif, you will be regular from now? Yes, Atif? I mean, you were absent like almost all the month, right?
Yes.
Okay. So also remember one more thing, it will be not so nicely written every time. So you have to understand the structure also. So for example, you have something like this. CHO in the presence of, let us say, NaBH4, sodium borohydride. Then you will count number of carbon atoms, 1, 2, 3, 4 carbon atoms. So write 1, 2, 3, 4 carbon atoms, and then this carbon atom will get the OH group. Okay. Similarly, if you have something like this, because I have H2 in the presence of nickel, then 1, 2, 3, 4, you will make everything as it is. And then instead of OH, you will write, instead of double bond O, you will write OH. Okay, write some products. Enough. I've given you 3 examples, write some other. Let me know when you're done. Okay. Please check your answers that you have drawn. So everything will be as it is. And this CHO will become CH2OH. Here everything will be as it is. This will become CH2OH. This double bond will change to OH. That's the only thing that is going to happen. To CH2OH. Write this down, everyone, please. Write a small note here. Notice tertiary alcohols cannot be prepared by aldehyde or ketone, aldehydes or ketones. Okay, please remember this. So again, from the conversion point of view, whenever you see a tertiary alcohol, then you should remember that the starting material or any intermediate reactant cannot be of any aldehyde or ketone. Okay. Right, next, by reduction of carboxylic acid and esters. Wait a second, Hamza, I'm looking at it. Yes, that is perfectly fine, not a problem. Right, next. By reduction of carboxylic acid and ester. Now, write a statement. Carboxylic acids are reduced to primary alcohols using strong reducing agent, and we use LiAlH4, lithium aluminium hydride. Again, this reaction is also very easy to remember. We have R, C double bond O, and we have OH. When I use LiAlH4, then this oxygen is going to break and you will add 2 hydrogens on this carbon atom. So I will be getting R, this carbon atom will get CH2, and everything is as it is. Nothing has changed. Okay, only this carbon atom is getting what? Hydrogen. So in the first step, I will add LiAlH4. In the second step, I will add water in order to get the OH form. Otherwise, it will be O negative and Li positive, something like that. So in order to get the OH form, I will add water. So you will see that in many reactions, we are adding water in the second step. Okay, the second step, we add water. For example, if I have, let us say, CH3, C double bond OH, and we have the same reagents here. So it will be what? CH3. This carbon will get CH2 and OH is as it is. Remove the oxygen, add 2 hydrogens. Remove the oxygens and add 2 hydrogens. Suppose you have some ring, cyclic rings like this, and you have COOH here. You're using the same reagents, and you will be getting CH2OH. Please write the product for this one. And what should I give you? Actually, that's it. If I use LiAlH4, then add water, I will be getting CH2OH. Okay. Or if you're writing it like this, then also it is fine. This means the same thing. Okay. So see, slowly, I hope you are more comfortable with these type of reactions rather than the haloalkane, halorine. So haloalkane and halorine is the main barrier in organic chemistry. Once you cross that barrier, what will happen? You will understand all the reactions and they will become easy from now on. Okay. But please focus on the patterns that you are seeing here. Please focus on the patterns here. Right next, ester are reduced to. Right next, esters are reduced to alcohols, and they give mixture of two alcohols. And they give mixtures of two alcohol. So I have an ester like this, R, C double bond O, O, R dash. Okay. So in this case, I can use LiAlH4, or I can also use sodium in the presence of C2H5OH, sodium in the presence of ethanol. Now, in this case, what is going to happen? The CO bond will break. Which bond will break? The CO bond. Okay. The CO bond will break. Please remember which bond is breaking. CO sigma breaks. Because we have here what? C double bond O also. So C double bond is not breaking. CO is breaking. Okay. CO is breaking. And what is going to happen here? You will give hydrogens to carbon and hydrogen to oxygen. So from RCO, you are going to get RCH2OH. Okay. And from here, what you are going to get, you will get then one hydrogen to this oxygen, and you will be getting hydrogen, oxygen, and R dash. Is that clear? So no, please tell me how to
Yes,
form
sir.
the product. Okay. If you have CS3, C double bond O, O, and you have CS3, and we are using, let us say, sodium in the presence of C2H5OH, the presence of ethanol. I will be getting here CS3, C, H2OH. This is coming from this part. Okay, plus I will be getting a CS3OH, and this is coming from this part here. So look at the patterns here. Please look at the patterns. I hope you're comfortable with breaking bonds and the forming the product. Write an example and tell me the product. CS3, C double bond O, O, and then you have CH2, CS3. In the presence of LiAlH4. What is the product formed? Tell me, guys. In this case,
CS2, CS3, CS3.
नहीं जोर से बोलिए आतिफ.
Sir, you get 2 CS3, CS2OH.
I will be getting from here also same thing, and from here also same thing, right? 2 carbons here, 2 carbons there. So I will be getting 2 moles of CS3, CH2, OH. Did everyone get this product? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
But others? Heba, Kulsum,
Yes,
Hamza,
sir.
guys? Yes? Okay. Fine. Write a note. Reduction of aldehyde. ketone and esters in the presence of or using Na(C2H5OH). Okay, so what are we using? With sodium and ethanol is called Pvt reduction. Pvt reduction. Oh, sorry, not Bain, Blaine. Blaine. Pvt reduction. Done, everyone? Yes or no? Please see me. Okay. Okay, right. Next, this is very, very, very important. Put here as many stars as you want. Put as many stars as you want. This is very, 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 very important. Okay, you can't forget this. You can't afford to forget this. Okay, you always have to remember revising it. And please write the topic. That is, this is which one? Fourth, right? By using Grignard reagent. By using Grignard reagent. Okay. So what do we have? We have any carbonyl compound. We have any C double bond O. Please look at this. Don't write anything. C double bond O. Plus we are using any RMGX. You're using any Grignard reagent. Once we have these two compounds, we should have a C double bond O and RMGX. In this case, we know that this carbon is having delta positive due to electronegative atom attached to it. So we have delta negative. Now here we have magnesium. Magnesium is a metal. Metal has a tendency to lose electron. Metal has a tendency to lose electron. And that is why it is giving electrons to R, which is making it delta negative, and Mg will be delta positive. Now in this case, attack will be coming from this R group onto this particular carbon atom, which is containing delta positive charge. Now, as soon as this R will attack on the carbon atom, what is going to happen? This carbon will break a bond and it will give the electrons to oxygen, because carbon cannot form 5 bonds. And you will be forming, please see, all of the bonds like this, it will be as it is. There is no change here. We have broken a bond with team C and O. That is why we are having CO. And this oxygen gets MgX. Okay. And this carbon, it forms a new bond with R. Where is this R coming from? This R is coming from Grignard reagent. This R is coming from Grignard reagent. And then on further hydrolysis, what happens? This OMGX, it goes away. So we'll get hydrogen here and OH here. Hydrogen attaches to oxygen and then OH attaches to magnesium. So these carbon atoms, the bonds with carbon atom is as it is. There is no change in those. We have this one bond with carbon and the other bond with carbon, and we get here OH. And here in the below, we get the R group. This R group is, again, just to remind you guys, it is coming from Grignard reagent. It is coming from Grignard reagent. Okay. So what is happening here? What is happening here? Please write. When Grignard reagent is treated with aldehyde or ketone, they form an addition product. ठीक है, pi bond था, pi bond break हो गया, and you have added on carbon atom and R group and oxygen MgX group. So that is the addition product. This is your addition product. Okay. and addition product. Then you write on further hydrolysis. On further hydrolysis, they form corresponding alcohol. They form corresponding alcohol. Done, everyone? Yes or no? Please tell me.
Yes, sir.
Okay. Now see, we'll start and look at the different types of carbonyl compounds that we can have in aldehydes and ketones. So the first one will be formaldehyde, and you will remember it as it is. Okay, you'll remember it as it is. Number one that we are going to look at is number one, formaldehyde. Okay, what is formaldehyde? It is methanol. That means a carbon atom with double bond O, and both the groups that is attached to carbon is hydrogen. Okay, is hydrogen. So formaldehyde, in bracket you will write no R group. That means you don't have any alkyl group. I hope you guys are comfortable with alkyl groups now. Alkyl group can be CH3, C2H5, C3H8, anything it can be. Okay, R group is any alkyl group. It has no alkyl group, no carbon atom. Okay. Now what is going to do? It is going to attacked by RMgX, let us say. So this R will attack on this carbon atom. It is going to form, first of all, see, you will get R carbon, hydrogen here, OMGBr, OMGBr. And then further on hydrolysis, what it is going to do on further hydrolysis, R, this carbon will have these hydrogen as it is, and this OMGBr will become OH. Now in the product, you can see there is one R group. That is why it is primary, 1 degree alcohol. No R group, say one R group in the product, one R group. Okay, so from no R group, it is going to one R group. Please remember this in formaldehyde. So as an example, if I have, let us say this is what, HCHO plus CH3 MgBr. First, I will treat this in the presence of dry ether, because magnesium, whenever we have Grignard reagent, we are going to have what? We are going to have dry ether. In the second, we are going to add water. When we add water, what is going to happen? We'll have CH3. Okay, this CH3 is coming from the Grignard reagent. It will add to the carbon atom with 2 hydrogens, CH2OH. Okay, so for those who don't understand this, please write it like this: hydrogen, double bond O plus CH3 MgBr. CH3 is going to attack here. First of all, it is going to make CH3 carbon double bond, carbon single bond O. MgBr will attach. These hydrogens are as it is. Further, it is going to, on hydrolysis, it is going to form CH3C. These hydrogens are as it is, and OH. Okay, and OH. So you start with methanol, and you are going to get ethanol. Okay, so see what is happening here: addition of one carbon atom, addition of one carbon. You can have addition of 2 carbon atoms, 3 carbon atoms also. How? Please see here. We have same things: hydrogen, C double bond O, and hydrogen. And I am adding here CH3, CH2, MgBr. Okay, I will write the product directly. The first case we have dry ether. The second case I have water. Please see here. This CH2 will attack on this carbon atom. Okay, so this carbon atom will have 4 bonds. 1 bond will be OH. The 2 bonds will be hydrogen and hydrogen as it is. And here it is getting attached with what? Here it is getting attached with this CH2 and CH3. It is getting attached with CH2. Wait a second. CH2, CH3. Okay. This CH2, CH3 is coming from the Grignard reagent. समझ में आ रहा सबको? Yes or no? Please tell me, guys.
Yes, sir.
What about others? Kulsum, Hiba,
Yes,
Hamza,
sir.
Krishna. Okay. Can I move on? Yes or no? Please tell me.
Yes, sir.
Just a minute, sir.
Okay, okay.
Done, sir.
Okay. Right, next, second one. All other aldehydes. That means how many R groups you will have? You will have one R group. Okay. So you have something like this. Let us say, let me write R mgx like this. R mgx plus you have carbon, one CS3 group here, and the other is hydrogen and double bond O. So you can see that it is aldehyde, but it is not methanol. It is not methanol. What is going to happen? This R group is going to attack. So R group is going to attack on this carbon atom. Okay, and it is going to form the R carbon, the CS3 group here with the hydrogen here, and OMGBr addition product. On further hydrolysis, R as it is, CS3 as it is, H as it is, and we are going to form OH, right? You are going to form OH. So this is what? 2-degree alcohol. Now, as you can see that this R group which we are having in the Grignard reagent, it is getting attached on the carbon, which is what's having carbonyl carbon. Okay, it's getting attached on the carbonyl carbon, and you're going from one R group to two R groups. Okay, you start with one R group and you're going to two R groups. So if you have, let us say, CS3 MgBr plus carbon connected to CS3, double bond O, and one hydrogen, it is an aldehyde. We are going to get, first of all, CS3. The CS3 will attach this carbon atom. Carbon, the CS3 is as it is. Here we are having hydrogen and OMGBr. And on further hydrolysis, it is going to give me CS3, carbon, CS3, hydrogen, and OH group. Now here, I hope you guys can see that this is my CS3, and this is the CS3, which is coming from the Grignard reagent. This is the CS3, which is coming from the Grignard reagent. Okay. You can have some big Grignard reagent also. You don't have to worry. For example, if you have something like this, let us say MgBr plus carbon with CS3 and one hydrogen. We have a double bond O. Now what is going to happen? This particular carbon atom, which is attached with magnesium, it is going to attack on this carbon atom here, the carbon atom that is containing the carbonyl carbon. Okay. Now what is going to happen? So I will just remove this MgBr and I will write it like this. Okay. It gets attached to this carbon atom. This is the carbon atom here. This carbon atom is having one oxygen. It will attach with MgBr. One CS3, it is as it is, and one hydrogen, it is as it is. And on further addition of hydrogen, it is going to give me, this is going to give me CH, and it has CH3 OH. Okay, so you can write this also as OH, or rather, wait a second. OH. Okay. So this part that we have here, this is coming from the Grignard reagent. Okay, this is coming from the Grignard reagent, and you can see that we have one carbon, oxygen, and the other carbon. So this is the carbon that we are having. This is the oxygen that we are having, and this is the carbon that we are having. This part is already there in your aldehyde that you have. Okay, this part is already there in your aldehyde. So, and you can see that there is a bond which is formed between carbon and the carbon of aldehyde and the carbon of Grignard reagent. Okay, this is also known as, these type of reactions are known as coupling reactions, where you make carbon-carbon bonds. Done all of yes or no? Please tell me. Any doubt in making product? Yes or no? Please tell me,
Yes,
guys.
sir.
Kulsum, Hamza, Hiba, any
No,
doubt?
sir.
Yes, Kulsum. No.
No doubt.
Hamza, आपको okay. Right. Next one. Third case. Ketones. Okay. In ketone, what are we going to have? 2 R groups. Okay. 2 R groups. So let us see, you have RMgX plus C double bond O, R group here, and another R dash group here. Okay, let me write this as R double dash here, and this is R. Okay, now what is going to happen? So as earlier, this R group will attach on this carbon atom, it will attack there, and it is going to form R carbon, R double dash, R dash. This will get what? Tell me, क्या होगा? OMG X. Then on further hydrolysis, everything will be as it is. C, R double dash and R dash and OH. Okay, and we all can see that this R is getting attached here and it is here. So it starts with 2 R groups, and in the product it has how many R groups? 3 R groups. Okay, so this is what? 3-degree alcohol. Acha, how many of you have a doubt that why do we write R dash or R double dash? Tell me now. Do you know what is the difference between R dash, R double dash, and R? Are they different? Are they same? What does it mean?
They are different.
I mean, it does not mean there will be always different. It means that they are not necessarily the same. They can be different. Okay. So if you can have all of the R as CH3 also, that is also correct. But it is not restricted to CH3s only or to same R groups. It can be different. It does just means that it can be different. So for example, if I have CH3Mg Br plus I have here, let us say, C double bond O and CH3, CH3. What session do you have, Kulsum?
Counseling session.
Which session?
Counseling session.
For which subject?
No, like overall counseling. Like what should I do next?
What should I? Achha, you have like career counseling.
Yes,
From where?
from Delhi.
From Delhi. Okay. Let me know how does it go.
Okay, sir.
Okay. हाँ अच्छा ये कब एंड होगा आपका काउंसलिंग सेशन?
I'm not
Any
sure.
idea? Not sure. Okay. If it ends before the class, then you will come back. Okay.
Okay, sir.
Okay. Chalo, bye.
Thank you.
Thank you. Okay. So what happens here? The CS3 will attach on this carbon atom, and you will get CS3 carbon. These CS3s are as it is, and I have here OMGBr. On further hydrolysis, we get CS3 carbon, CS3 OH, and CS3. Okay. So see, the important thing is that you understand what are the carbon atoms that we have from the aldehyde. Okay. So from the aldehyde, we are going to have these atoms are already there in your aldehyde, right? These atoms are already there in your aldehyde. And what is coming from the Grignard reagent? This part here, it is coming from the Grignard reagent. This part here is coming from the Grignard reagent. Okay. Because in the questions, they will ask you to make a Grignard reagent, which will give you this product. Done, guys? Just now, please tell me.
Done, sir.
Okay. So we have seen three things till now, right? Ketones, all other aldehydes, and formaldehyde. Okay. So you have a question in NCERT. Let us do that question first. Okay. I'll tell you how to deal with this type of questions. Write this down first. All of you done writing this down? Yes or no? Please tell me. Let me know when you're done writing, okay?
Done, sir.
Okay, just a second. So see, in this question, what they're asking you that how are you going to form these alcohols? That means these are what? These are products. Okay, what are these? These are products. So we have CS3, CH, CH2, OH, and we have a CS3 group here. Okay, so this is the product. I hope itna samajh mein aa raha sabko. Yes or no? Please tell me step by step. Right? Yes or no?
Yes, sir.
Right? What about
Yes,
others?
sir.
Huh? Right? Okay. Yes. Now they're asking you that how are the following prepared by the reaction of suitable Grignard reagent? That means they have not told you what is a suitable Grignard reagent. You have to find that Grignard reagent. So I will write this just as R MgBr, let us say, okay, MgBr plus Grignard reagent on methanol. So they're reacting Grignard reagent with methanol. What is methanol? You have one carbon atom and it is an aldehyde. That means it is what? Carbon atom with a double bond O. It is an aldehyde, so it will have hydrogen and hydrogen. Correct? It will have hydrogen and hydrogen. Now I will write it in the terms. अच्छा, अब ये बताइए. We all know when I form alcohol using any carbonyl compound and Grignard reagent, out of these carbon atoms, 1, 2, 3, 4. Now, out of these atoms, tell me which atoms are present here. यहाँ पे कौन-कौन से atoms हैं? Product के कौन-कौन से atoms हैं? Please write in chat ना. Write in chat. What are the atoms we already have in methanol? कौन से atoms है वो? 1, 2, 3, 4, 5 में से. Correct, Atif? हाँ, okay, fine. अच्छा, got it. I have given उसको भी number दे दिया है हमने, by the way. No problem. I can understand, but waiting for Hamza, Hiba, and Krishna. You understood the question? Yes or no? Please tell me, Hamza and Hiba. Hamza, Hiba, Krishna, tell me. Did you understand the question?
No, sir. Can you repeat it again?
Okay. Okay. So earlier case, ये हम बता रहे थे ना यहाँ पे that see these are the carbon atoms that are coming from your carbonyl compound. This is the carbon atom that is coming from your Grignard reagent, right? You saw
Yes,
this, yes
sir.
or no? Right. Similarly, you have to tell me which of these carbon atoms are coming from the methanol. Which of these carbon atoms are coming from the methanol? Okay. And I mean, which of the atoms are coming from methanol? एक और atom होगा methanol में. Hamza, you're right about that. There is one more atom that is coming from methanol. Krishna, you understood the question now?
Yes, sir.
Send the answer in chat. यहीं पे Zoom के chat में. Hiba, I am waiting for your answer. Krishna, how many carbon atoms do I have here? Tell me now. In methanol.
1.
Then I'm asking about methanol, by the way, not Grignard reagent. I'm asking, इस methanol से product में कौन-कौन से carbon atoms है या कौन-कौन से atoms है in general? I have labeled it ना हिबा 1, 2, 3, 4, 5. उसके हिसाब से बताइए. हाँ, okay Krishna. And one more atom will be there ना? One more atom होगा, एक और atom होगा methanol का वहाँ पे. Other than carbon it will be, right? ये oxygen तो होगा ही ना? This oxygen will be present here, right? Yes or no?
Yes, sir.
Krishna. ठीक है? Okay. Yes, Hiba, correct. Now, once you have identified that, first of all, you will identify this and you will get better at this. Don't worry. Okay. Now you can see that it is obvious. Tell me, Hamza, Hiba, and Krishna, isn't it obvious?
Yes, sir.
It is obvious, right? Hamza and Hiba, you answer me, please. Yes. Okay, fine. After we have found that, then what you are going to do, you are going to break this. Now that means this part here, it is coming from what? Tell me. This part here, it is coming from
Grignard reagent.
Grignard reagent, right? So you will form the Grignard reagent as it is. Okay. So how will you form the Grignard reagent? You'll form it like this. You'll form CH3, CH, and since the bond of CH is with CH2, this CH will have a bond with MgBr, and here you'll have a CH3. Plus you will write H, C double bond O, H. In the first step, I will have dry ether. In the second step, I will be using water, and I will be forming CH3, CH, CH2OH, and a CH3 here. You got this? Yes or no? Please tell me, guys. Krishna,
Yes, sir.
Hamza, Hiba, समझ में आया सबको? Okay. Now in the second question, we'll have again RMGBr plus HC double bond OH. This is already given to me. That methanol is produced. Methanol is in the reactant, and we are getting now. Can all of you please send me the structure of Grignard reagent that will be used to produce this? Yes, very good, Akshay. Looking at your answer, okay. Krishna, correct? Yes, very good. Hamza, correct. Hamza, आप ये रिंग स्केल से बना रहे हैं? Hamza, are you making those rings with scale? No, okay, fine. It seems like very straight. Oh, freehand, nice. I'm waiting for answer from Hiba. Hiba and Atif also. Atif? Is Atif here? I don't know. Got disconnected before. Hiba, I'm waiting for the answer. Yes, correct, Hiba. Okay. Also, you can be asked about some conversions also. So they can ask you questions such as, how will you convert? Let us say you have methanol, ethanol. Okay, so whenever you have aldehyde to, whenever you have aldehyde to alcohol, you will remember this reaction with the Grignard reagent. Okay, so what is happening? Methanol. What is methanol? You have H, C double bond O, and H, and you have to form what? You have to form ethanol, which is CS3, CH2, OH. So you should remember that this carbon and oxygen are present here. Okay, and then you will figure out that this CS3 will come from RMGX, Grignard reagent. Okay, so what is the reagent that you are going to use? You're going to use, first of all, number 1, CS3 MgBr. Okay, in the second step, you are going to use water. That is it. Can you see that happening? Yes or no? Please tell me, guys. Can you see that happening?
Yes, sir.
Yes.
Right? Anna, take care. Write this down. Let me give you some more questions, maybe. Okay, there are a few questions that I have to give you regarding the reducing agent. There's one question specifically that I want to give you guys, and that is from NCERT. वो पहले complete हो जाए. अच्छा, before that, I will explain that later. There are 2 more substrate that can be used with Grignard reagent. Okay, so please write esters. Next one is esters. Now, esters, it is not present in your NCERT, but still learn this. It is going to be helpful. It is going to be helpful. Okay, see here. What do we have in esters? We have, let's take an example of CS3, C double bond O, OCS3. Okay, OCS3. Then again, here we have the delta positives and the delta negatives. You have to remember delta positive, this is delta negative. And we are going to treat this with RMGX. And my RMGX, let us take this R as RMGX. Now here again, this is my delta negative. So my delta negative is going to attack on this carbon atom, and this pi bond is going to break. It is going to oxygen. Oxygen will get the MgX. So we'll have CS3. Then we have we have carbon. We have OMgX. And here we have OCS3 as it is. And here we are having the R group. Here we are having the R group. Now, as you can see, it is a very similar case to what we saw in the last class of CS3, COH, OH, and R, right? So when you have 2 oxygen atoms on the same carbon, it becomes very destabilized due to what? Due to its high electronegativity. And that is why this is going to automatically cleave like this. You're going to automatically cleave the OMgBr, OMgX or OMgBr with this CS3 like this. Okay, so this is going to go away, and then you're going to get CS3 carbon. Now this oxygen will get a double bond. This oxygen will get a double bond. That was with CS3, and you will get a R group here. And this is now what? This is ketone. And you know what is going to happen if you have ketone and RMGX? If you have ketone and RMGX, it is going to be CS3 carbon, OH, and the R group will add here. This R group is adding here, and this R group is already present. But both of these R groups that we have here, this R group is also coming from the Grignard reagent, and this R group is also coming from the Grignard reagent. Okay, so please remember this. All of these R groups are coming from Grignard reagent. This is how the reaction happens if we have ester. Now, if a similar ester is present, and if we are having rather than CS3 here, so please remember that this OCS3 does not have anything to do. This OCS3 is obviously going to get away. But if I have something like this, let us say you have hydrogen, carbon, double bond oxygen, and here you have O any R group. Any R group is there. Okay. And we are treating this with, let us say my Grignard reagent is R dash mg x, R dash mg x. Then what is going to happen? ये तो आपको पता लग रहा है that this is going to get away, right? OCH3 जा रहा है यहाँ से OR चला जाएगा. OR will get away, and what you are going to get is, you get the hydrogen as it is, the carbon as it is, the oxygen with a hydrogen OH as it is, and दो bond आपके break हुए, so one will be R dash, the other will be also R dash. Okay, the other will be also R dash. Both of these R dash are coming from where? These are coming from the Grignard reagent. The Grignard reagent. Okay, so in this case we have this structure here. R dash are coming from the Grignard reagent. So the bonds which are breaking are C double bond O, may say pi is breaking, and what is breaking here? COR bond is breaking. And what is the bond that we are going to form? We are going to form two bonds with CR dash. This R dash is coming from the Grignard reagent. Okay, form होगा यहाँ पे form लिख लीजिए. You got an idea how to make the products from esters? Yes or no? Please tell me.
Yes.
Yes, sir.
Okay, and also you can see that we have also learned one reaction of esters getting converted into ketones. Okay, esters getting converted into ketones. Chali. After this, you write here. लिख लिया आप लोगों ने? Yes or no? Please tell me. पहला reaction
Yes, sir.
था. This was our first reaction that we did. This was our second reaction that we did. Next it's oxidane. What are oxidanes? Oxidanes are when you have oxygen is in a ring and that 3 atom ring. So we have oxygen. We make the RMgx first. Again, here we are using RMgx here. Okay. Plus you have oxygen which is bonded to CH2. It is also bonded to CH2 like this. Okay. Now this carbon will have delta positive. This oxygen will have delta negative. This R will have delta negative. So this R will attack on this carbon atom here like this. It's going to attack here. And what is going to happen? This bond will break. And you will get R CH2 CH2 OMGBr. Then I hope you can see that already. If I add water here, I will get R CH2 CH2 OH. In this case, this R is coming from where? This R is coming from the Grignard reagent here. Okay, this R is coming from Grignard reagent. Done everyone? Listen, please tell me. एक reaction लिख लीजिए यहाँ पे. So you have CS3 MgBr plus CH2 carbon CH2. First step we are using dry ether. Second step we are using water. What will be the product? Done everyone? Yes or no? Please tell me.
Done, sir.
Done, sir.
Yep. Done na? Hamza, Hiba, done?
Done, sir.
Done. Okay. So I hope you are getting the product CS3, CH2, CH2OH, right? Yes or no? Please tell me.
Yes, sir.
Propanol. Yes? Okay, fine. Good. Great. Now, write a remark on reducing agent. Okay, so first of all, regarding LiAlH4, it is a strong reducing agent and it reduces, किस किस को reduce कर देता है ये भी देखिए, it reduces COOH, it reduces COOR, it reduces COCl, जो कि आपने नहीं पढ़ा है, but still it reduces COCl also. Okay, and what does it reduce? It reduces also, we have seen that it reduces ketones also, right? Yes or no? Please tell me.
Yes, sir.
And we have seen that it reduces ketones also. That means it reduces C double bond O, है ना? So we say that LiAlH4, अच्छा, LiAlH4 is reactive. LiAlH4 क्या है आपका? It is reactive in nature. Next we have another reagent which is important for you guys is sodium borohydride NaBH4. Okay, so NaBH4 हमने कहाँ पे पढ़ा है बताइए? We have learned NaBH4 only for aldehyde and ketones. Yes or no? Please tell me. We have learned
Yes,
for
sir.
aldehydes
Yes,
and
sir.
ketones only, है ना? And you can see that it is not reacting or it is not giving any reactions for carboxylic acids and esters. Yes or no? Correct? Right, guys?
Yes, sir.
Carboxylic and esters, they are only reacting with what? LiAlH4. LiAlH4. So when you have sodium borohydride, it is not going to react with, you are writing, it is mild reducing agent and it reduces, अच्छा इन सबको ये किस में कन्वर्ट करता है? LiAlH4 to it converts it to CH2OH. okay, सबको किस में कन्वर्ट कर देगा ये? CH2OH में. okay, and it reduces only what? It reduces only, अच्छा CHO नहीं लिखा हमने यहाँ पे, CHO भी लिख लीजिएगा. वेट अ सेकंड, एल्डिहाइड तो लिखा नहीं हमने, कॉमा दे क्या लिख लीजिएगा? CHO to CH2OH. Mild reducing agent and it reduces only aldehyde, ketones and acid halides, COCl. Okay, acid chlorides. And it reduces these things to what? And it reduces these things to CH2OH. Okay, right. So write it like this to alcohols. And that is why we say that NaBH4 is selective. Okay, lithium aluminum hydride is reactive, NaBH4 is selective, and because it is selective, it selectively reduces certain elements. Okay, so you have a question in NCERT which is asking you about the product which is going to form. If I have, wait, is the question? Is it here? No. लिख लिया था आप लोगों ने? ये सुनो, लिखा था आप लोगों ने? नहीं लिखा था?
Written, sir.
Written, all of you? Okay. So see here, in this question, you can see that we have NaBH4, okay? Now, NaBH4 and we have two carbonyl compounds. What is this? This is going to be ester. This is ester. And what is this? This is ketone. Now, NaBH4, it cannot reduce ester. It can reduce only ketone. And that is why what is going to happen in the product, you are going to write, convert this to OH, okay? And this will be as it is, CH2, C double bond O, OCH3, nothing happens here. And here we have what? This is what? Aldehyde. This is aldehyde. And NaBH4, it reduces aldehyde. That is why we are going to get CH3, CH2, CH, CH2OH, and there will be CH3 as it is. Okay? All of you got this? Yes or no? Please tell me, guys.
Yes, sir.
Okay. Write this down, write this down. Done, everyone? Yes or no? Please tell me.
No, sir.
No. Done, everyone? Okay, सबने?